Hello, good morning. My name is Professor DEVANGI PAREKH from Shivsha Institute of Computer Application. Welcome you to this online video series of BCA department. In this particular course of computer organization, I expect to cover the various aspects of computer design where you will be seeing the basic topic like logic gates, flip-flop, integrated circuit, number system, etc. We shall be also looking at the topic like control unit design, design of the memory system, instruction cycle, stack organization and addressing modes. Then we shall be moving towards the IO organization, direct memory access and memory organization. By understand all this topic, we will know how the computer internally works, and then that's why this topic is quite important for learning. So now in this course I am going to cover the four basic unit. First unit is all about various digital components used in the organization and design of the computer system. Second unit is all about representation of data. Third unit we will see the architecture of the central processing unit. And in the last unit we will going to discuss the organization and architecture of the input output processor and memory unit. So let's start with the basic terminology which is related to this subject. So for that, firstly we need to understand the word computer organization. For that we have to understand what does the computer means. So in general terms we can say that computer is an electronic device which performs the various tasks according to the instruction given. A computer system can be divided into two functional entities. First one is hardware and second one is software. The hardware of the computer system consists of all the electronic component and electromagnetic device that is comprise the physical entity of the device. Computer software consists of all the instruction and that data of the computer manipulate to perform the various data processing tasks. Now let's see three basic important terminology of this subject. First terminology is computer organization. It describes the function and the way computer components are operated and the way they are connected together to form the computer system. Second important term is computer design. Computer design is a concern with the hardware design of the computer, and it will determine what hardware should be used and how the parts should be connected. Third important term is computer architecture. It describes the structure and the behavior of the computer as seen by the user. It includes the instruction format, the instruction set and the technique for accessing the memory. Now let's see the basic component of every electronic machine, and that is logic gates. So in general term we can say that logic gates take some input. According to the behavior of this gate, it will generate one output. The basic technical definition of logic gate is the manipulation of the binary information is done by logical circuit, which is known as logical gates. There are different kind of logical gates are available in computer system. So there are three basic logical gates. One First one, the basic logical gate is AND gate, second is OR gate and third one is NOT gate. There are two type of universal gates are also available. First one is NAND and second one is NOR gate. Logical gates are basic building block of any digital system. In this type of electronic circuit, take one or more inputs and will give one output based on the certain logic. Now let's understand all this logic gate in detail. In all this logic gate, we need to understand three basic criteria. First criteria is symbol. Then second criteria is algebraic function or boolean function of this logic gate. It shows the relation between input and output. Third criteria is truth table. This table is used to represent the Boolean expression of the logical gate function is commonly known as truth table. It shows each possible input combination of the gate with resultant output depending upon the combination of the input. Now let's see first gate, which is AND gate. This is the symbol of AND gate, and algebraic function for AND gate is output is equal to A into B. So we can consider AND gate is a logical multiplication of two numbers. So binary information is represented in 0 and 1 form. Now consider we can give two input A and B to the logical AND gate. So the output will be resultant into A into B. So for example, there are two inputs are there, 0 and 1 for logical AND gate. So there are 2 raised to 2, it means 4 possible combinations are there. So the combinations are 0 0, 0 1, 1 0 and 1 1. So the algebraic function or Boolean function of the logical AND gate is A into B. So arithmetic multiplication is performed between the A and B input. So in multiplication we know that 0 cross 0 is 0, 0 into 1 is also 0, 1 into 0 is also 0. In last condition only, where input A and B both are 1, we will get our output. So in last condition we can say that the NAND gate will generate the output. It is same like logical multiplication. Now let's see next another gate, which is OR gate. So here is the logical symbol for the OR gate. The Boolean expression or algebraic function for OR gate is output is equal to A plus B. So we can say that arithmetic addition is performed as the output. So again consider two input for this gate, A and B. In binary information, we are going to represent the binary format, which is represented as 0 and 1. So two state are there. For the two state, again there are 2 raised to 2 possible combinations are there. So 4 possible combination we will see as 0 0, 0 1, 1 0 and 1 1. So for this input pair we are going to perform the arithmetic addition for output. So 0 plus 0 in arithmetic addition we will give output 0. 0 plus 1 we give the output 1. 1 plus 0 again it will generate the output 1, and in arithmetic addition 1 plus 1 will also produce the output 1. So for the OR gate we can say that if any of the output consists 1 or any of the output is a high, then we will generate our output in OR gate. Now let's consider the next third gate, which is NOT gate. NOT gate will produce the opposite result of the input. So if we consider the input is 0, then it will produce the output 1. Consider 1 as an input, then it will generate the output as 0. This is the logical symbol for NOT gate, and this is the Boolean algebraic function. We can pronounce it as a bar or a dash. So it will generate the exact opposite output for given input. We can consider it as a complement for input. Now let's understand about the universal gate. Universal gate, first one is NAND gate. NAND gate is a combination of AND gate and NOT gate. So let's see the symbol for NAND gate. So here we can see this is the symbol for AND gate, and this dot denote the NOT gate. So here is the whole symbol denote the NAND gate symbol. Now let's understand the algebraic function for NAND gate. As I say, it is a combination of AND and NOT. In algebraic function, we can also see that this A cross B star is denote AND gate, and this bar is denote as a NOT gate. So final algebraic function for NAND gate is output is equal to A cross B into star. Now let's understand the truth table for NAND gate. So as I say, NAND gate is a complement of AND gate. It will work just opposite to the AND gate. So to understand the truth table of NAND gate, we have to recall the Boolean function for AND gate. So in AND gate, we will not get our output in one condition only, where A and B both having one has input. So it will work just opposite to the AND gate. In NAND gate, we will not generate our output in one condition only, where A and B both having one has input. Now let's understand another universal gate, which is NOR gate. NOR gate is a combination of OR gate and NOT gate. So here in the symbol we can see that this is the symbol for OR gate and this dot denote the NOT gate. Now let's understand the algebraic function for NOR gate. Output is equal to A plus B into bar, where A plus B denote OR gate and this bar will denote the NOT gate. Now let's understand the truth table for OR gate. So in this gate we can get our output where both input is 0, which is just opposite to the OR gate. NAND gate and NOR gate is known as a universal gate because any logic gate can be constructed by using this logic gate. The conversion of different logic gate from the AND gate and NOR gate we will see in next lecture. Now let's understand two other gate, which is XOR and XNOR. Firstly, we will understand XOR gate. So here is the logical symbol for XOR gate. So in XOR gate, we can observe that this part denote the OR gate. Just this addition curve line at the input side make it has a OR gate. Now let's understand the algebraic function for XOR gate. So output is equal to A XOR B is a Boolean expression for XOR gate. This symbol denote the XOR gate. Now let's understand the truth table for XOR gate. So in XOR gate, the XOR gate will be generate the output in the condition where both input A and B is in different state. For example, here A is equal to 0, B is equal to 1. Here A is equal to 1 and B is equal to 0. A and B both having different input. In this condition only XOR will generate the output. Now let's understand the XNOR gate. XNOR gate is a complement of XOR gate. So it will work just opposite to the XOR gate. Here is the logical symbol for XNOR gate. The algebraic function for XNOR is A XOR B bar. Now let's understand the truth table of XNOR gate. As I say, it will work just opposite to the XOR gate. In the XOR gate, we will see that the XOR gate will generate the output in the condition where both input is in a different state. So in this XNOR gate, we will not get our output in two condition only, where A and B is having different state. In other word, I can say that in XNOR gate, the XNOR gate will generate the output where A and B having the same state. For example, here A is equal to 0, B is equal to 0. So both is having same state, then XNOR gate will generate the output. The other condition is A is equal to 1, B is equal to 1, both state is same, then XNOR gate will generate the output. By summarizing this video, we have first understood what is computer organization is, and then we have seen different type of logical gates with their symbol, boolean expression and their truth table. Thank you.